Hi, everybody. Thanks for joining us today to discuss operating and supporting HBase, best practices and improvements. So I know HBase has been in the market for a while, and a lot of people support it, use it, and we'll see what we have done so far in making it better for the customers. So just a round of introduction. My name is Tanvir Karada. I'm with Hortonworks for more than 2 years with the technical support team, and I have been working on HBase for quite a while now and have learned how difficult or easy and how many issues, what kind of issues, how you can tackle it. So that's my day in, day out, and it's been fun so far. And we have Enos.
Hey, I'm Enos. I'm a committer and PMC member for HBase, Phoenix, and Hadoop. And I'm also working on the HBase and Phoenix development team at Hortonworks.
Great, thanks, Enos. So just to give you guys an outline, what we'll try to cover here today is, I mean, HBase is an enormous topic, but I'll try to cover as much as possible and whatever provides the most value based on whatever we have worked so far. So we'll cover some of the tools that we use to debug issues. We'll try to take a deeper dive into the top 3 issues that we have been working with, some of the corner cases, difficult ones that have been an issue to debug and get to conclusion. And I'll briefly talk about SmartSense as well, which is an add-on on the Hortonworks distribution, how it can help you to make your life easier with HBase. And Enos will cover the last outline topic of improvements, better operability metrics, and measurements that you can use to track how your HBase is doing. I'll actually kick off with tools. I'm assuming everybody here knows how HBase works, so I don't want to spend time going through the overview, but digging right into the tools that we cover. And the most important tool that we have been using so far is HBase UI, and it helps enormously. I mean, there has been a lot of work done on HBase UI to help debug and troubleshoot issues. And some of the key instrumentation that we use in UI is to identify load distribution, collect debug level information, runtime configurations that are in play when your cluster is up and running, and how to track RPC tasks. There's a lot more information that is available in HBase Master UI that can be handy. Compaction progress, bunch of other non-RPC tasks that you can track, but these are some that we use on a day-to-day basis to quickly debug and resolve the issues. Just want to bring up the UI that we use for load distribution tracking. Once you are on the UI page, you can list out all the region servers. I've blurred out the region server list information, but that's usually where the host name is, which is registered with HBase. And as you can see, the distribution shows requests per second, how your region server is interacting with clients on data interaction. So there you can see requests per second, and the read request count and the write request count is a consolidated number since region servers were restarted. So you can easily track if there is a specific region server being hit hard, hotspotting, that can very easily be identified through this UI on what load distribution looks like. If there is a region server being hit hard for write, you can easily go into the UI and track it down. And once you pop the UI open, it's not going to be your base tab. The base tab is going to be on base stats. You click on request and it will pop this information up for you. Base stats also has a request count, however, it's not broken down in read and write. So a better place to go track it down is on the request tab itself. Moving on to the next one. Let's say your region server is running slow. Your RPC queue time is going up, and you want to track down what really is going on at the JVM level. And the number one debugging opportunity is to go and look at the thread dumps. How do I get to the thread dumps? Okay, traditional method is, okay, go ahead and find the JVM process and issue a kill -3. The thread dump gets dumped into the out file. What UI does in HBase world is it has made life a little bit easier. It just a click button away on the UI. go ahead and find your debug dump link on HBase UI header, pop it up. It will give you last few lines of logs, thread dump, as well as other RPC tasks going on. I've tried to include a snapshot. I was not able to put the whole thing, but that's what it will look like. Once you click on debug dump, it will populate a text file that you can start tracking down. And usually, if you want to track a hang or a slow process, you want to collect recursive debug dump. You can run a curl call and run it in a loop every 10 seconds, 15 seconds, whatever you want to basically collect the information for a minute. And it will, a curl call for this particular URL for debug dump should be able to provide you with that information. The next is runtime configuration. So usually we put most of the configuration information like zookeeper timeout or memstore information in HBase site.xml. However, there are a lot of configurations that get picked up on at runtime from HBase default, where you can go and find, again, we rely on HBase UI to provide us with all the runtime info. So it's not just HBase, but what all the other HDFS client, Yarn client, any relevant information that is needed to interact with HBase gets consolidated and populated in the UI. So if you want to track a configuration for HDFS, like HDFS short circuit, whether it's enabled or not, you can go in and look into the UI and identify whether it's turned on or not. Any other configuration that you want at runtime while JVM is in progress, you can go and track it down into that runtime config screen. That again is a tab in the header. You can quickly get all your relevant configurations in there. Moving on to the next one is RPC calls. Let's say your compaction is in progress, or your RPC client calls are in progress. Any other tasks that can be tracked as an RPC, non-RPC task, client operations, you can pretty much track all of their information through UI as well. So it comes in handy when you want to track whether the client is interacting or a table is compacting or mem stores are flushing, it will get listed in these tasks UI. So being in support, we need to get to this information quickly, and UI is just phenomenal. There has been a lot of improvement, and I think the improvement keeps happening on UI front. It has been great help and blessing. The next tool that I want to switch gears is to HBCK. However, I'm covering a lot about HBase inconsistencies later on in the slide. I'll go ahead and save the HBCK topic for that later session when we hit the inconsistencies topic. So I want to dig deep, directly jump into our day-to-day issues that we deal with. And the number one is region server stability issues. So let's say you're building out an HBase cluster. You run default configs, and you start putting load on it. So the number one call that we usually get is, hey, my region server is randomly crashing. Can you help me out with it? And that's when we start going into and looking into issues. Usually it is standard, like not enough heap is configured. But what I want to cover here is some of the corner cases, difficult to debug, identify, and scan through whatever information we can get from logs, but still not really an easy task to conclude. So I want to bring out some of those corner cases just so that you guys are aware what HBase does as runtime, which could be outside configs and the code itself. Just to give you an overview of how region server crashes usually manifest. So Zookeeper does an awesome job orchestrating HBase region servers and HBase master availability. So the promise of HBase is random read-write access in a high availability manner. So whatever data you want to interact with, it's always going to be available. And the way Zookeeper manages that promise is by sending heartbeats to all the region servers and HBase masters. And there is a timeout associated with if region server or master do not respond within the time frame, Zookeeper considers it as, okay, I'm not this your region server, you didn't respond back within this time frame. I'm going to issue a shutdown so that your regions can get assigned out to different region servers and data interaction can continue to happen. And that's where the whole instability picture also comes into this conversation or equation. Let's see how how that unfolds. The number one culprit we have seen so far is GC pauses. And in JVM world, GC is an inevitable evil. And that comes into picture with the whole region server equation as well. So what we see is these are region server logs, and I'm grateful to the HBase community that we have started printing this out in the region server logs. As you can see, it clearly says JVM pause for 82,000 milliseconds, which is beyond Zookeeper default timeout of 40 seconds. So Zookeeper sent a heartbeat. Region server JVM was garbage collecting for more than 40 seconds, failed to respond back, and Zookeeper issues a shutdown. The second statement here pretty much prints out the same thing, elaborating what GC logs were, what state GC was in. And we have CMS set up as default for Hortonworks distribution. That's just additional prints to identify where you can do some tuning. Based on our experience so far, we have come up with some of our GC tuning best practices recommendation. Ideally, the last 5 parameters, actually the first 2 are region server heap size. You can go as high as 32 GB. Anything beyond that is going to have lack of uncompressed or compressed pointers on JVM side. So the new generation size is bumped up to 2500 megs. Perm size is something that we set up for until JDK 1.7. It's eliminated in Java 8, so it's not going to be in play. However, survivor ratio does help to prevent heap fragmentation and prevent promotion failures. And CMS occupancy fraction, we hint JVM when to start GCing, which is at 50% of occupancy rate. And the last parameter indicates JVM to use CMS occupancy fraction heuristics instead of the default ones, which can go as high as 90%. So it will wait for heap to get up to 90% to start doing GC. Besides that, in the standard HBase world, you may also want to test out G1 as an option besides CMS. I mean, CMS is what is shipped with Hortonworks distribution by default. Some of the corner cases, this is an interesting issue that we worked on, where in the GC logs we digged into it and saw that the user clock was pretty low. However, the real wall clock was going beyond 31 seconds. It was a classic head scratching movement. We were not able to identify where really to look for information. We had to dig into the system level information. Since HBase is so tightly coupled with the underlying operating system, the underlying platform, and networking, we need to consider all equations, all factors contributing to that equation. And going further into var log messages, system logs, we were seeing that when just before region server was showing those pauses, we noticed this write level SCSI target messages in var log messages. We ended up enabling debug logs for the disk drivers. I mean, it was hinting us towards a block while writing data onto the disk. And evidently enough, we were able to see in the firmware driver logs that under heavy load, writes to the disk were getting paused for 30 seconds, and that's where we're getting pauses in JVM, eventually crashing the region server. This was an interesting situation. It took quite a while getting involved with the hardware vendor, having them enable firmware logs to eventually get to the root of the problem. But that's where we found the solution in the end. Moving on to the next one, this was again a corner case. And in this event, region server JVM pause monitor was clearly saying it's not GC related. So GC was running smooth. There were no issues with GC logs. However, we still ended up seeing pauses really huge enough to crash region server, huge enough for Zookeeper to issue a shutdown. It was bringing region server down. So we had to start digging into against system level information. Nothing was evident on region server, Zookeeper, or master logs. And we ended up finding leads in dmessage buffer logs, in ring buffer logs. It was not even getting printed in the var log dmessage as well. We pulled up dmessage buffer logs. That's where we saw that it was related to a CPU halt. And turned out to be a Red Hat issue, a Red Hat bug, where I printed out the root cause where it says that CPU work queues can be backed up to 10 minutes. Pretty serious. Your CPU just halts for 10 minutes. Nothing else on the box is going to run. And we found more leads into the data node logs as well. It was running. Data node daemon was running on the same box. We were able to see, it was not showing pauses, but we were able to see that the loggers were kind of getting halted for 120 seconds or more seconds as well, which led us to believe that something on the box is pausing it. Yes? That was the disk I/O. It was a driver upgrade for the disk from vendor. Okay. Those are some of the corner cases. How to mitigate the problem. This is something that I don't really recommend, but if you want to put a quick fix just to get your cluster going, get the development or data interaction going, what I would do is go through all your HBase logs, region server logs, identify how big of the pauses you're seeing, and try to come up with a timeout value. The Zookeeper timeout value can be modified to mitigate the problem. I mean, there could be a situation where the pause could be even bigger than what the biggest one that you found. But in this case, let's say 165K is the biggest pause you're seeing in region server logs, and consider going up to 180K just to mitigate any pauses that are lower than that value. Again, this is not my favorite workaround. What it does is if you have a higher timeout, Zookeeper will take even longer to identify if there are any region server or master failure. And it just does not deliver on the high availability promise that HBase has. So make every effort to identify what is causing these pauses. But in the end, if you want a dirty fix to just get your cluster running, go with this workaround. It's just a workaround. Don't use that as a solution. So moving on to the next hot topic is performance. Let's say you have your cluster up and running, region servers have stabilized. You want to start putting some load, and you're running into performance issues. So before I get into it, just an overview. What really happens in HBase region server when you're trying to write data? So there are writes getting built up in region server mem store, which is in the physical memory, but at the same time, you have this write ahead log mechanism, which is a direct write to HDFS, which goes onto the disk of the data nodes. And that's where your performance is mostly going to get capped at. H-file, mem store writes are instantaneous. It's going to consume that write immediately and put it in the mem store and flush it eventually to the disk. You won't see a lag there. But if your wall files are lagging, you're not going to see performance. So it's critical that your HDFS it's keeping up with these wall files as and when they're coming. So it thoroughly depends on the throughput of your HDFS data node pipeline. Prior to HBase 99, it was pretty difficult to track down which data node you really need to target if you're seeing slow write performances. And thanks to HBase community again, since HBase 99, they do print out. We print out the slow data node time, how long it took. So anything more than 1,000 milliseconds is going to get printed into region server log, and it also shows you the pipeline, the data nodes that are involved with that wall file consumption. It's pretty neat to track it down this way. Prior to HBase 99, we used to have we really had a convoluted process to identify which data node to target on, and that involved identifying which RPC call queue lengths are growing, based on that, go into the WAL file for those region servers. Every region server has its own WAL file. And identify the most recent WAL file that is being written into, run Hadoop FSCK with -files, -blocks, -location flag to see which data nodes those writes are really going on to, and then target those specific data nodes to see what really is happening. And we have identified that there are some faulty data nodes causing the slowdown. You take them out of the cluster, let the blocks get distributed out, and we are back in business. And we have done that. We have done this whole exercise with a couple of our customers just to track down where it's slowing. And you could clearly see that when these slow WAL file writes are in action, the RPC used to shoot up for those specific region servers. So it was pretty taxing, but fortunately we have a lot of improvement in place to track down those data nodes pretty early in the game. Read performance. There is great caching mechanism in place for doing great reads, but one important thing to consider is that caching comes into picture for subsequent reads. Let's say you're reading the data for the first time, it has to make a trip to the disk. To improve read performance from the disk for the first read operation, it's important that the tables are, the regions are compacted. Compaction is where region server, the store files are consolidated into one big file. And it happens every time it qualifies for those compaction mechanisms. So let's say you have a region having 100 store files. HBase has to go through each and every one to track down where your data is. So compaction makes it work even better. You have to make sure, sometimes customers actually go in and turn it off based on some other recommendation or whatever they have whatever they have identified through some blogs out there that it's better to turn it off. But it's not good to turn it off completely. At least run it once a day or once a week whenever you have a low traffic period. It does put some pressure on your HBase cluster, but do keep it running. Don't completely turn it off. The other improvement you can have is by having a balanced cluster. So by default, balancer runs every 5 minutes, and it balances out your regions evenly across the cluster. If you have it turned off by any reason, chances are that you have uneven distribution, and if that uneven distribution causes clients to hit particular region server, which has the most sought after data, that region server is going to get hot pretty soon. It's going to run out of handlers, resources to service those request processor requests, and you will see slowness during read operations. So there are several other recommendations out there for improving your read performance. We can have a whole 40-minute session just to cover other tuning parameters, but these are the ones that I've seen work the best when you want to quickly just get your cluster performing better when it comes to reads. Just to deep dive into it or show you how you can identify what really needs to happen. So do you need to really major compact a table or not? That is mostly, again, identified through UI. Once you go into the HBase region server UI, there is a key metric out there which shows block locality. If your block locality is off, the goal is to get it as close as possible to 100%. If you are off, if you're like seeing 8, 9 single-digit block locality, it means region server is going through remote calls. So region server is representing a set of data, and it doesn't have it locally. And Hadoop is all about having local data. So if block locality is not there, it's going to make remote network call, expensive calls to get that data going. And what major compaction does is, the first step it does is just brings all the relevant data local, and then go ahead and compacts it and builds a bigger store file to service requests just from the single store file itself. One good way to identify is to go into UI and see what your block locality is, and then go from that point onwards. Balancing the cluster out, again, it's a shell operation. You go in and see if balancer is turned on or off. If it's off, just kick it off, or you can also run it manually. However, it runs every 5 minutes. It's good to just have it turned on. Some of the other configs you can use for read performance is enable HDFS short circuit so that it doesn't go through the entire trip of hitting name node, identifying which data node, and getting that block information. If the block is local, it's going to just read through the short circuit socket. And one option is also to have your HBase client scanner set to 100. It's the amount of rows it will fetch in one RPC call. You can tune it based on how big your rows are. If you have really wide rows, then it may be a good idea to tone it down a bit. Inconsistencies. So let's say you have set up your cluster, it's stable, and it's giving you good performance, and now you want to start interacting with data. A challenge with HBase is there are several places where traces of data are on it. The most important place is HDFS, where your store files are, but besides that, there is Meta, which keeps track of which region server is hosting what region. And just to clarify, Meta is not the table description information like other Hadoop components like Hive. It's about which region is hosted on what region server. And then we have Zookeeper, which maintains Z nodes, where the region servers are, regions are, and again, there is quite a lot of information on master memory as well. So there's a distribution of data across multiple components, multiple levels, and that's where potential inconsistencies can come into picture. How do those inconsistencies manifest? So a client wants to interact with the region, it's going to say region, mostly it's going to come back saying, oh, the region is not serving, just because their data interaction is not, or potentially the region is in transition. So inconsistencies lead to region in transition that again, you can identify through HBase master UI if you are having issues with regions being hosted on a particular region server. And there will be retries, timeouts. Those are some of the manifestation of the problem. What are the tools that you can use to identify and fix those inconsistencies? So HBCK, which I tried to cover in the first few slides and mentioned is going to be covered later, this is where we are covering it. So what I have here is what HBCK does. HBCK can be, it's a great tool. You run it on the command line on any client machine. It confirms whether HBase is healthy or not. So it comes up with a report in the end. This table is having 0 inconsistency. This table is having 5 inconsistency. Whatever it is, it's going to spell it out for you. And it also comes with fixed options. Let's say you have a hole on your HDFS. It's going to be, you can run a fix HDFS hole option to get that corrected. So it provides an option to identify and fix. However, it's not a silver bullet. So there are going to be difficult situations where you don't have a straightforward inconsistency, and it has issues multiple level, HDFS, Meta, Zookeeper, and an opportunity not be there for HBCK to fix it in a straightforward manner. And that's when you have to like dig deeper into the logs, see where the problem is, and go by fixing that problem from that point on. But yeah, 90% of the stuff gets done with HBCK, so it's really handy that way. Again, HBCK won't run if you don't have your master initialized. So you have to go through, make sure your master is up and running. You can get to the UI. You see the regions distributor. Of course, there are going to be regions in transition if there is relevant inconsistency, but your master should be up and running initialized for HBCK to run successfully. Some of the examples that I have here for inconsistencies, like when you run HBCK, it's going to tell you found in Meta but not in HDFS. So information is in Meta but not in HDFS. Go ahead and fix an HBCK with fix Meta option to get this corrected. The other inconsistency that we have seen is there is a hole in region chain between X and Y, region X, region Y. You need to create a region info file and also plug the hole on HDFS. So again, HBCK comes with options to take care of both the problems. So HDFS orphans fix is going to go ahead and create the region info file, and fix holes is going to go ahead and fill that hole out, which the inconsistency is complaining about. This inconsistency where it says lingering reference file. So splitting region is a highly orchestrated and complex process, multiple moving parts involved, and And in the end, when the region splits successfully and the daughter regions are online, it's supposed to clean up the reference files. Occasionally, due to some known or unknown code issues, those lingering reference files don't really get cleaned up. How would you go about fixing them? There is an option, fix reference files, run it, and it will take care of it. We now have seen occurrences where you run HBCK. I mean, there are prior inconsistencies. You run HBCK with the right fix option. It takes care of everything. And you're left with 0 inconsistency. So at that point, HBCK is not reporting any inconsistency. But you still go to master UI and shows that regions are in transition. And that may seem concerning. But again, since we have some information being harbored on HBase master memory, that's where it comes from. So a simple fix to get by this problem is just restart HBase master. And we have seen 99% or probably 100% of the time this problem goes away just by restarting master. And master is mostly doing the admin work. The data interaction, all the action is happening on region servers. So it's pretty safe to go ahead and restart master if you're seeing this problem. Again, HBCK is not straightforward. This is an inconsistency where you may have to dig deeper into the logs. I mean, it's saying it's not on HDFS, not on Meta, and it's not roasted on a region server, so you may have to dig deeper into the logs to see what really is going on, look through the other inconsistencies being reported. HBCK best practices. When you run HBCK, it may, depending on the size of the cluster, it may scroll several lines. And it may not be able to track what error messages it's reporting. Just go ahead and redirect it out to a file and review it once it's done. On a large cluster where you have multiple tables and multiple tables having multiple regions, my advice is to run it per table. So if you see there is a problem with table X, go ahead and run HBCK just for that specific table. That's the most it can get granular. It won't go into column family level debugging. So use that option if you have larger clusters. And there is a fix all flag which runs all the other fixes in the background, which is the repair option, but not a great option. It has a tendency of going into loops where it can potentially go ahead and merge split regions. So go by what your HBCK is reporting, some of the examples that I showed, and then identify the right fix for it. SmartSense, a tool that we started shipping with, Hortonworks started shipping with HDP 2.3. So U limits, Zookeeper having dedicated drives, transparent huge pages, and swappiness. All that is common knowledge in HBase. Well, you want a functional operational HBase cluster, then go ahead and set this up right. But if you don't have it set up right, SmartSense will do it for you. You basically run the agents. It will go scan through the boxes and identify if there is a problem with all this setup. Just a screenshot of how SmartSense looks like. It's integrated with HTTP with Hortonworks support portal. As you can see, right, it called out that transparent huge page is a high critical problem. Go ahead and fix it. Increase the no file, no proc limit. Some of the examples how it can be handy when you're running a busy cluster. That's pretty much it. I'm going to pass the baton to Enes.
All right. Thanks, Tommy.
Yep.
Thanks, Tommy. Okay. So I want to talk quick about like the again like what kind of improvements that we are doing inside the HBase community to help the lives of the operators and help the life of Tanvir, obviously, and then cause less problems to operate and to have HBase in a much more stable manner. So one of the other advices that I can give you is that as the guy on the right side says, you have to have monitoring for your HBase clusters. You have to have a solution, no matter whether if it's OpenTSDB, whether if it's Ganglia, whether if it's Graphite, whether if it's Unbiometric server. You have to have something that you can take a look at your monitoring and look at your metrics to understand what's going on. Why is this important? Is that HBase, unlike the other Hadoop ecosystem projects, is an online system. HBase, being able to have millisecond queries, being able to have very high throughput is very important for running HBase clusters and workloads. That's why having good monitoring there definitely helps a lot, identifying the problems early on, and then being able to understand what HBase is doing in the end, and then how to tune it better. So HBase definitely has a bunch of metrics. I think last count, it's close to 200 metrics being emitted from a single server. There are very, very good ones. They are very useful. There are not so useful ones as well. But like, for example, we are emitting GC times, we are emitting pulse times, we are emitting like just regular stuff like memstore, block cache usages, and everything. The replication, what is the replication lag? What is the replication backup? Your RPC call queue lengths and everything. Understanding these and making sense of these is a little bit harder. You have to at least have an idea of how HBase works. What does block cache mean? What does memstore mean? What does RPC queue means, for example? But after having a basic idea of the HBase at the architectural level, looking at these metrics to understand what's going on is really, really important. You can use OpenTSDB if nothing else is available. Ambari comes with a new Ambari metric server that does the collections for you. And every new version of HBase adds more and more metrics so that you can definitely take a look at newer things and take a fresh look at the things that was not exposed before. And as Tanvir talked about, region server and master UI also emits these metrics and shows these metrics already. So you can either take a look at your metrics or take a look at the region server or master UIs, right? So you need definitely higher level tools for looking at your metrics. So in Ambari, in the recent versions, we are shipping what's called the AMS server, and we are shipping a tool called Grafana. So again, like HBase has hundreds of metrics, and then how would you know what to look for and what this particular metric means and everything? That's why we actually grouped, did the dashboards in Grafana by default, which would show you in a grouped up way per region server, what's your RPC level view, what's your memstore level view, what's your memory view, and everything. And you can go and click expand these to actually see what's going on. It's also like these kind of things is also very important for looking at things across the servers. For example, you can take a look at the latencies from the disks for all your data nodes to see if a particular set of data nodes is having disk level problems. You can see it from metrics. If, for example, a particular region server is hotspotting, you can definitely identify it by looking at the metrics across all the region servers. So yeah, you don't have to use the AMS one, but you have to use or build your own similar tools to operate HBase better. Other things that we are trying to do in the HBase community to make, again, everyone's life easier is the Canary tool. It's a relatively new tool that's been developed and improved over the different releases. I suggest everyone to really use this tool to actually set up alerts for different Canary invocations. It can do actual reads and writes. It can do talk to every region server in round-robin manner. It can even talk to every region that your table has, does an actual read to every region that you have. So that, for example, if, for example, as Tanvir was talking about, if one region is not available, then immediately you will get a notification from Canary, and then that alert will pop up somewhere, right? Again, to the earlier points that Tanvir was mentioning about the inconsistencies in the metadata space, previously in 1.x release lines, HBase has the metadata in 4 different places, as we've talked about, the meta, the HDFS, Zookeeper, and the master memory. We are trying to simplify all of this and make this much more robust. So we are trying to basically remove, for example, Zookeeper from the one of the state stores and try to make the master operations to be fault tolerant so that the assignment process and the metadata is much more protected and much more consistent and much more simpler in the 2.x release lines. Definitely, we've talked about garbage collection related pauses and the constant struggle of having super big JVMs and doing like 100K operations per second on the region servers creates a lot of garbage and everything. So there's definitely work going on in the HBase community to first reduce the amount of garbage being generated. Second, also make it so that like HBase can work with bigger heaps and do more and more of heap rather than using the heap space. That is definitely going on. There's also work going on for the cases where the region server hotspotting or some other problem, the clients will bombard the region server, and then the region server goes into, it's already highly loaded, then it goes into another state where like it tries to keep up with the amount of requests coming in and everything. So we are doing like client backoff improvements and the RPC scheduling improvements to help with the case where like even if there's some slowness from the disk or from operating system or whatever, in a particular region server, at least the clients will back off. The region server is trying to cool down. So that's definitely going on. And the last point is, again, rolling upgrades and no downtime. This has been a pain point starting from like 0.94. We had the singularity and everything. So, but we're trying to make the life of the HBase operator a lot better. That's why we are trying to do no downtime and upgrades and rolling upgradable manner. I think that's all what we have. All right, thanks.